Welcome to Geometry for AP. Today we're going to learn about composites or compositions of rigid transformations. So please get the title up here into your notes. Let's get this vocabulary, just this one here will work. And of course our essential understanding on the title of our page. All right. So you can express all rigid transformations as compositions of reflections. So that is the interesting part. Compositions of reflections. All right. So we go to the first one. Key constants of a rigid transformation is that the figure, remember, is congruent. Its shape is the same and its size is the same. Okay. So there are only four kinds of rigid transformations. We've learned about all these by now. We've done a translation, we've done a rotation, we've done a reflection. Okay. And of course, there is also the glide reflection. The glide reflection is a rigid transformation, but it is a combination of a translation and a reflection. Okay. And do notice it says here that the orientations are the same, but these orientations are opposite. So our first theorem here is theorem 8-2, so you want to get that into your notes, and that is the reflection across parallel lines. So if you reflect a figure across, so we have, this is our original figure here. I'm going to highlight that in yellow, all right, and we reflect across this line right here in green, we get this shape right here. And then we reflect across this purple line, we get this new shape here, which is, we'll highlight in yellow, all right? But the thing is that when we reflect across this figure and reflect again, this is actually a translation now. The figure's oriented the exact same as the original, and so therefore, I'm going to get all these colors out of here so you can write those down. Therefore, this is a translation, but the amount of translation is 2 times the distance from here to here. Okay? So it's 2 times that distance. And in case you're not sure why, notice that in a reflection, this distance and this distance have to be the same, and this distance and this distance have to be the same. So if this is the one distance plus the other distance, that is 2 times the distance. Okay? So a reflection across parallel lines gives you a translation. All right. The next one we have is a reflection across 2 intersecting lines. So if we reflect across 2 intersecting lines, it is the same thing as an actual rotation. And the rotation would be the rotation of the number of degrees right here. So this is 20 degrees. This figure all the way over here to this one would become a 40-degree rotation. So if you reflect across 2 intersecting lines, it is a rotation. If you reflect across 2 parallel lines, it's a translation. And that's where they're talking about a composition of rigid transformations. All right. So again, composing reflections across parallel lines, we will reflect J across line M and then across line L. Okay, and so first we do our reflection to reflect J across line L, and then that gets us this image. Then we do our second step is reflect across line B, and so we get this image. And so therefore at the end, this is moved a total distance of 2 times the distance from A to B. And so that's where we have it's twice the length between those 2 figures. All right, this next one, again, we're doing a reflection across 2 intersecting lines. So we first start off by reflecting across line J, or I'm sorry, across line L. J goes reflect across L. Then our second step is, again, we reflect across the next line, which gets us this one. And so then at our end, we draw our angles, and so we end up with a 2 times the measure of the angle. And so if that's a 70-degree angle, this was a 140-degree rotation, because this angle plus this angle is the same as this angle plus this angle, because these 2 angles, angle 1 and 2, have to be congruent. Because remember, in reflections, the angles have to be the same, just distance is conserved. And so these 2 have to be the same. So if these 2 had to be 70, and we had the same amounts again, it's another 70, which is 140 degrees. All right. Know those 2 little theorems there. So what about if here we do this transformation? We know the vertices, we know the translation rules, we know the line of reflection rules. And we're going to do a glide reflection. So we're reflecting and then we're doing our translation here. So we start off, we use the translation rule. So we translate 0, -5. So that's 0 movement horizontal and 5 movement down, which gets us to here. So there's our glide part. And then our reflection would be reflected across the line. X is equal to 0, which is the y-axis, which reflects us over to here. And so there's our final answer. Now, I know this is 2 transformations, but we're only listing the prime marks because we want the final answer, not the processes in getting there. All right, so these are 2 for you to do. So it says graph the image of triangle PQR after a composition of the transformations in the order they are listed. So here's one. You do this one first, do this, then this, and graph that figure, and then you can get another graph. You can do this one, then this one. Okay, so pause the video, do those 2 problems, make sure you have on 2 separate graphs. We'll be checking that in class the next day. All right, and so here it says describe the composition of the transformations. Blue is the pre-image, so blue is the pre-image, red is the prime, and green is the double prime. So how do we go from each one to the next? So make sure you list those. So if I look at this first one here, you want to look at this one. Blue is the pre-image, and then we move to the red. So how do we go from blue to red? And that would be a translation. And I'll even put it in component vector form. So what did we move? We moved 1, 2, 3, 4, 5 horizontal and 1 up. So there's our translation vector. And then to go from red to green, we did a rotation of 180 degrees counterclockwise. And that would be my answer. So make sure you have the second one up here in your notes. And I would draw the picture. You can do a sketch of this. You don't have to necessarily have the graph. It might be nice to have the graph, but I want the rules also. All right, last one here. It says, find the angle of rotation that maps A onto A prime. So if you have to, you can go back and look at your notes and see what we said to do there. So make sure you have those for when we get to class and we can discuss those. I'll be checking for those answers. This one is a series of questions I would like you to answer. This has to do with the reflecting across 2 parallel lines. Let's see how you do with these questions. When you come to class, we will check the answers. Make sure you have something, make sure you have the questions written down along with the answers and the picture, because it doesn't mean anything if all you have is the answers with nothing to look at. All right. And finally, since you're done with the video, you may want to start pages 14 through 17, okay, so that you can practice some of your composite transformations. Remember that on Monday is a review day, and Tuesday is the test day, so we got that coming up. Thanks.